Okay, so today we're going to be making a tool in MATLAB that you might find useful, especially for presentations or animation visualization of data. So yeah, we're going to be making an animated bar chart. So anyway, just to show you guys what to expect so you don't have to watch the rest of this video if it's not what you had in mind. But it's going to be something like this, where we have the color interpolation depending on the magnitude or the value of something, and it's going to animate a time-dependent function over time in a bar chart manner. Alright, so the first thing that I'm going to do is I'm going to define the functions that we want to animate. Animate. Okay, so first that involves defining a time period. So let's just define it from t is equal to 0 all the way to 10 seconds, okay? Now we want to define the functions that the bar is going to follow. So let's just pick some random functions. Let's have this first bar do a quadratic. We'll have it go like this. T minus 10. Bar 2, we'll have that one also do like an opposite facing quadratic. That should be okay. And then we'll have our third bar. We'll just have this guy do a linear thing. Anyway, let's just see what these look like real quick, just so we can see if we, make sure that they're reasonable. Okay, let's see what we got here. All right. So this is the functions that they're going to follow. Seems pretty reasonable. Yeah, okay. You know what? I'm actually going to make this like 1/20th. Let's see what that looks like. I can go a little higher. How about just 1/10? There we go. Okay. And then I'll have this linear guy have a slope of 2. There we go. That looks better. Okay, so these are the functions that we're going to animate. So yeah, instead of, maybe you're given a presentation or whatever, instead of just given this data that, where the x-axis is time, let's make things a little more exciting. So let's make an animated bar chart. Alright, so the first thing that I want to do is set up the color interpolation. So let me show you this little thing real quick that's kind of neat. So here's the RGB sliders. As we go up from black, so everything's 0, 0, 0, RGB 0, 0, 0. So we want this to go from being black all the way to red in the most, the nicest way possible, which is probably going to look something like that, So then, yeah. So we can kind of see a pattern here. First, what happens is if we look at these, this blue, green, red is just separate functions, all right? In order to interpolate smoothly from black to red and get that rainbow scheme, first we want to ramp the blue up, and then once this remains all the way up, then we want to ramp the green up. And once green gets up, then we can ramp the blue down. And then from there, we can ramp the red up. And then we could ramp the green down. And there we go. We have a nice interpolation. So we are going to capture that mathematically. Okay, so let's kind of discretize this into steps. All right, so everything is 0. Blue has a linear part up, and then it stays there. As it stays there at the top, then we have green come up, so it ramps up linearly, and then our blue can finally ramp down, then our red can go. So each time I'm sliding it, that's a separate event that's happening. And if we were to draw this out, let's go ahead and draw this out. Hold on. Okay, so here's just an axis, okay, that I'm going to split up my events by. Okay, so let's get a blue color. So we said first the blue bar ramps up. All right, that's the first event. Okay, then the blue bar stays there. That's the second event. Then the blue bar comes down. That's the third, and then it remains down here the rest of the time. Okay, so now let's look at the green bar. Okay, so the green bar starts out at 0, right? And then it ramps up while blue is staying there, and then it stays there. Okay, and then it ramps down. So that is also the end of an event line right there. All right, and then finally the red one. So it starts at 0, it stays at 0, and then it starts to ramp up, and then it stays. Okay, and that's where we end. If I were to ramp down, then we'd be interpolating back down to black, since it'll end up at 0, 0, 0 for the RGB values, which is black. So this is where it ends. Okay, so these are the functions that we want. We want this this blue function, we want the green function, and we want the red function. Okay. Okay, so we're gonna define a parameter space. So let's just call each one of these tick marks 1, 2, 3, and then 4. Okay. And now let's just go ahead and go back to MATLAB and write the functions for these. Okay, so let's go ahead and program these functions in over the parameter space that ranges from 0 to 4. And I'm going to define these as anonymous functions using this @ sign. And the reason why I want to do that is because what we're going to be doing is we're going to be mapping the values to our parameter space. So let's just keep it as a function for now. You'll understand why by the end of this video probably. So anyway, so the blue curve, let's look at that. Blue at x. Okay, so let's use the Heaviside functions, the Heaviside step functions. So it's going to start out, it's just x, right? And it's going to turn on at 0, and it's going to turn off at x equals 1. Okay, so that's that portion of it. So that's this leg right here. Okay, the next part is just going to be 1 times it turns on at 1 and turns off at 2. Okay, and then it's going to go down. So this line right here that ramps down, that's let's see, that is 2. No, that's 3 minus x times Heaviside of x minus. So it turns on at 2 and turns off at 3. Okay. And then it just stays off, and it stays at 0. So that one's done. Okay. Let's do the next one. So green. So it starts at 0. It doesn't turn on until 1, and that is the line of x minus 1. So we have x minus 1 turns on at 1, and it turns off at 2. And then, so that's that first ramp, and then it stays on. So 1 times Heaviside. The 1 function turns on at x minus 2, or not x minus 2, but x equals 2. And then x minus 3 turns off. And just so you guys know, this Heaviside function, basically what this returns is everything to the left well, if we were to look at just heavy side of x, everything to the left of 0 is 0 and everything to the right is 1. So what you can do is you can basically, multiply the heavy side step function by some function f of x and have everything, have the domain, or have the function left of 0 be turned off at 0 and the right of the function is there. And then you can shift this over using this. So instead of turning off at 0, you can turn it off at 1, whatever. That's just some background on that anyway. So we just did this leg right here in the green, and now we need to do the ramp it down. So that function is 4 minus x, and it turns on at 3 and off at 4. Yeah, okay. And then it stays off from there. Okay. Last one. Let me put a semicolon there. I don't like when I see those highlighted equal signs. It's kind of annoying. Okay, so red does not turn on until x equals 2 right here, and then it ramps up, and that ramp up function is x minus 2. So x minus 2 times heavy side, it turns on at x minus 2, or it turns on at x equals 2, and turns off at x equals 3. And then we just have that 1 because it stays level at 1 heavy side, x 3. And I'm just gonna keep it right there. I'm just gonna say it doesn't turn off because anyway, because it's the end of the thing. So we can keep it defined at x equals 4 just in case. So let's go ahead and take a look at this. So let's open up a new figure. Hold on. And let's plot these. So anonymous functions, you got to use the easy plot. So let's plot blue over the range of our parametric domain, which is 0 to 4. Let's just check this real quick. Then we have our green, and it should look like what we have drawn right here. So let's go ahead and run that. And yeah, it looks fine. So this blue curve is our blue, that red curve or orange curve, whatever it is, that's the green. Yeah, I probably should have set the colors on this plot, but whatever. We get the idea. And yeah, looks fine. Okay. So we are good right there. Okay, so let's go ahead and set up our loop and get the bar chart set up first. So I'm going to set up a for loop. We're going to loop through our time array. So for I is equal, starting from the first index all the way to the last. And what we're going to do is we're going to get the values for each bar at that time. So I'll call this, the value for the bar 1 is going to be bar 1 of I. Bar 2 like that, and bar 3 like that. Okay, so those are the values. Okay, so now let's create the actual bar objects. So the first bar we'll just refer to as 1. We'll call bar, which is the function in MATLAB for the bar graph. Okay, so this is going to be the first bar. It's going to have a value of B1, and we'll just add some random width. We'll see how that looks. 2, similar stuff. So, whoops. Okay. Okay, 3, 2, 2, 3. Yeah. Okay, so that should create the actual bars. And since we're in a loop and we want to update the values like this, you do that by calling a pause. So I'm just going to pause for the, I guess the time step up here, 0.01, so 1/100th. and we'll see how that goes. Let's just go ahead and run it. Oh yeah, I forgot to also put, hold on and stuff. Let me just call a figure just to get it up like that. So that's where this bar chart is going to go. And also at the beginning, I want to clear the current axis, so that'll prevent it from basically it just plotting over itself. Okay, so let's go ahead and check out how that looks. So yeah, we have the axes being cleared at the beginning. It finds the new value of it and it animates it. Okay, so right now I'm not doing anything with this color, but we'll see how it looks when we run it. Okay, so it's definitely animating. Okay. I'm guessing this, yeah, this is the quadratic one. So I'm guessing it's going to come back down a little bit. Let's see what happens. But yeah, you can see how the axes are changing. So I'm going to want to lock those axes probably. And it's going to come on down the slope of the quadratic. Okay. Yeah. All right, so yeah, we're fine on that. We need to lock those axes and then add color to it. Okay, so the first thing I want to do is I want to find the max values of the functions that we're plotting. And the reason why I want to do that is so that we can map them accordingly to get our colors, and also so I can lock the axes at the right place. So let's do it like this. Let's look at let's call A the max of bar 1. So 25. So what about the max of bar 2? 10. Max of bar 3? 20. Okay, so 25 is the all-around max. I'm going to write that down. Max is equal to 25. And then I'm going to, right before we do that, I'm going to just redefine the axes of this to be from, I don't know, whatever width, doesn't really matter, it's a bar chart. And so that's the total width of the axes, and the height has to go to 25. And now I'm going to want to set the colors. So these are my 3 bars. So the way I'm going to set the color is by doing this. I'm going to say set bar 1. I'm going to set, I want to set the face color, and I'm going to give it an RGB value. Okay, we're going to do that for each one, for each of our bars. So this will be bar 2, and this will be bar 3, and we're setting the face color of it, and we're going to give it a value. So the way we're just going to call these anonymous functions that we have up here, these red, blue, and green functions right here. So we're going to call red of whatever, blue of whatever, and green of whatever. So I'm just kind of filling out the bare bones of this before I actually start putting in numbers. Okay, so all we have to do is plug in numbers associated with the value of the bar graph at that point, and then we get the corresponding color. But remember that our functions, our RGB functions, are only defined over a parametric domain that goes from 0 to 4. So what we have to do is we have to take the magnitudes and squash it down into that that range of 0 to 4. And the way that we can do that is just divide by the max value. So I'm just going to say for bar 1, we'll take the bar 1 value, which is B1, and we'll divide it by the max. So B1 over max. So what this is going to do is this right here, right now, everything is squashed down to from 0 to 1, because the highest we can get is maximum over maximum, which is 1. So everything is going to be between 0 and 1 And then all we need to do is multiply it by 4. And what that does, that squashes it between 0 and 4. So let's go ahead and do that. That needs to be B2. That also needs to be B2. B2. Let's add our 4s in. 4. That needs to be B3. 3. And B3. Okay, so let's go ahead and check that out now. Okay, so let's go ahead and run this and see what happens. All right, so it looks like these two guys are pretty slow. I guess we can pick a different function for them, but yeah, see how it interpolated nicely? Now it should get to red. All right, awesome. And as these increase, their color will also interpolate from or along the color spectrum as we defined it. And you can always play with those color functions as well and get a different interpolation scheme. But yeah, so red, now it's coming back down, writing the parabola back down, and this one's writing the parabola up since it was just a t squared. This guy's just going to be linear all the way. It's not going to move much. So yeah, and then there we go. All right, well, that looks nice. I'm going to go ahead and close that out. So this is the code. That's how you make an animated bar chart. All right, enjoy.